Hello, this video is on section 6.6, which is titled Trapezoids and Kites, and the learning target for this is to verify and use properties of trapezoids and kites. So of course there's two shapes we're going to be talking about. First one is trapezoid, and in a trapezoid it is a quadrilateral with exactly one pair of parallel sides. So it doesn't have 0, it doesn't have 2, it has exactly 1. So for example, if we have this trapezoid here, we could say that these two are the sides that are parallel, and of course you can see that these clearly have different slopes and they're not parallel to each other. So by definition, this is a trapezoid. Now if you get even more specific, we'll get into isosceles trapezoid, but first I want to go over the names of the parts of the trapezoids. So the two parallel sides are called the bases. If this was even flipped around to where the parallel sides or this way, the parallel sides would still be called the bases. So in most cases you'll see it top and bottom, but the base is the one that's the parallel side. Now the other ones that are not parallel are called the legs. So that would make then the top and bottom sides of this one the legs. Now when you get to the inside of the trapezoid and we're referencing to the angles on the bottom are base angles towards each other. So if you're talking about base angles, the ones on the bottom, where there's an angle that's separating a base and a leg, those are base angles. Then when you look at the two angles on top, those are also base angles, since you have a base and a leg separating each of the angles. Now what you cannot say is that these two angles are base angles and those two are base angles. The base angles are the ones where they are angles separating the base and the leg, and they are along the line of the base. The side separating them has to be the base. It can't be the leg that separates them. So that would make those two base angles, and that would make these two base angles. Alright, so you have to have a base separating the two base angles. Then we get more specifically into an isosceles trapezoid. An isosceles trapezoid is a trapezoid where it still has exactly one pair of parallel sides. The top and the bottom could be the ones that are parallel, but then it also has legs that are congruent. So the two sides that are not parallel to each other are congruent to each other. And since we have an isosceles figure, that also means that this angle is congruent to this one, and then this top base angles are congruent with the other ones. So in an isosceles trapezoid, base angles are congruent every single time. Not these two and not those two. The base angles are the ones that are congruent to each other. One more thing in an isosceles trapezoid is that it has congruent diagonals. So I can also mark this up to show that it has congruent legs and that it has one pair of parallel sides, but it also says that the diagonals are congruent to each other. So the diagonal AC is congruent to the diagonal BD. Just like a rectangle. An isosceles trapezoid is just like a rectangle with the diagonals, that they are congruent to each other. Then there's a cool little thing that's talking about a mid-segment of a trapezoid. And what I mean by a mid-segment is a line that connects the legs that cuts the triangle in half. So starting right here at this one leg, it's going to go across to the other leg and cut it in half. Now this mid-segment right here, I'm going to call it EF. This mid-segment is parallel to the bases. So in a trapezoid, bases are parallel to each other, and the mid-segment is also parallel to those two bases. That is a requirement of the mid-segment of a trapezoid. And then what it's also saying is that the length of the mid-segment is the average of the length of the bases. So if you add base AB and CD and then divide it by 2 or multiply by 1/2, that is going to give you the length of EF. This is how you find the average of the length of the bases. Add them up and divide by however many there are. In this case, there's 2. So the average is the length of the midsegment. Okay? Now moving on to a kite. A kite is incredibly unique to where it's the only one that really doesn't talk about anything of the opposite sides or parallel or thinking about any angles. The only 2 things that happen in a kite is that you have consecutive sides that are congruent and the opposite sides are not. So if you look at AB, it is a consecutive side with AD because they're touching. So those 2 sides are congruent. And then looking at BC to CD, those are consecutive, so that means that those are congruent. You cannot say that the opposite ones are congruent, which would make AB and CD opposite sides. So those aren't congruent. And the other thing is that the diagonals are perpendicular. So if I create a diagonal connecting BD and AC, those form 90-degree angles all on the inside right there. And on the very last sheet I have here is a flow chart that's very, very important that you get this copied down in your notes. What I'm about to fill out is a flow chart that's kind of describing the hierarchy or tier list of all of the quadrilaterals that we've talked about. So the very first thing I want to start with, as general as possible, is a quadrilateral. It's anything with a 4-sided shape. It doesn't have to have anything specific with the angles, side length, parallel sides, or diagonals at all. It's as broad as possible. Then the 3 types that branch out from this quadrilateral. The first one I'm going to put over here is a kite, which is the last one that we've talked about. This has diagonals form perpendicular lines, and consecutive sides are congruent, but opposite sides are not. Then on the far right, I'm going to put trapezoid. This has exactly one and one only sets of parallel sides, and then if you get more specific from the trapezoid, I'm going to include isosceles trapezoid. An isosceles trapezoid is a trapezoid, so that's why it's next in the flow chart. But the only thing that's different is it has one set of congruent sides that are not the bases, so the legs are congruent. Then going down here into the middle, which is the bulk of the types of our quadrilaterals, the next broad part from the quadrilateral is a parallelogram. And remember, a parallelogram has opposite sides congruent, opposite sides parallel, and opposite angles congruent. The diagonals also bisect each other. Then the 2 different types of parallelograms that we've talked about are rectangles and rhombuses. Rhombuses or rhombi, either one. So rectangles have all 4 right angles, and rhombuses have all 4 congruent sides. Both of these are parallelograms, so that's why they branch off separately. And then the last one that we talked about is a square. So basically the way this flow chart works is everything that is towards the bottom is a type of figure that's in the top. So every single kite is a quadrilateral. Every single rectangle is a quadrilateral. Rectangles are also parallelograms. You cannot have a rectangle unless it's a parallelogram and a quadrilateral by definition. So that also means that every square is a rectangle and a rhombus. A square is all 4 sides congruent and all 4 right angles or 90-degree angles. This flowchart is 99% going to be on the test, on the off chance that I don't put it on there, but more than likely it will be on there. It's a very important classification on quadrilaterals. You're going to see it on the ACT, so I feel like it's very important that you understand what it means and what's happening. The most broad thing is at top. Sometimes you may see it in the middle where quadrilaterals here and everything's kind of spread out in directions. But just to fit it on this sheet of paper, I put it up top and I had everything branching out from the bottom underneath. So follow this. It's very important. This is the last section before the test, so we will review. And yeah, thank you.